On May 9, 2025, China made headlines worldwide as its revolutionary maglev train reached an unprecedented speed of 620 miles per hour mph during a test run in Shanxi Province. This remarkable achievement positions the train faster than most commercial aircraft, which typically cruise at speeds between 550 to 575 miles per hour. The success of this high-speed rail technology is a significant milestone in China's ongoing efforts to lead global advancements in transportation, particularly through the use of magnetic levitation maglev technology. Maglev technology operates on the principle of magnetic levitation, allowing trains to glide above tracks without physical contact, which vastly reduces friction. This leads to not only higher speeds but also a smoother travel experience for passengers. The specific maglev train that achieved this speed utilizes high-temperature superconducting HTS technology designed for efficiency with minimal energy loss and noise. Previously, the fastest operational speed for trains on the Beijing-Shanghai line was approximately 350 km per hour, around 217 miles per hour. The new maglev train's speed effectively doubles that, showcasing a significant leap in capabilities. The implications of this achievement are considerable. The potential for drastically reduced travel times could reshape domestic travel across China. For instance, a journey from Beijing to Shanghai, currently taking about 5.5 hours via traditional high-speed rail, could be completed in just 2.5 hours on the new maglev train. This presents a compelling alternative to air travel, which often suffers from delays and congestion, especially in major airports. Geopolitically, the advancement of China's maglev technology highlights a stark contrast with the United States, which has struggled to develop its high-speed rail systems due to bureaucratic hurdles and budgetary constraints. While proposals for a 200 miles per hour rail link between Los Angeles and San Francisco are still in discussion stages, China has already surpassed that speed, actively deploying operational trains. The origins of maglev technology are also a point of contention in discussions surrounding this achievement. Initially developed by Siemens in Germany, some reports suggest that aspects of the technology were appropriated by China during a testing phase, raising concerns about intellectual property and technological transfer. This historical context contributes to the ongoing narrative of competition in transportation technology between nations. Beyond mere speed, China's maglev project serves as a broader statement about its ambitions for global leadership in technology and infrastructure development. By achieving such high speeds with eco-friendly transit solutions, China is not only modernizing its transportation system but also promoting sustainable development. The environmental benefits of maglev technology cannot be overlooked. The reduction of friction leads to less energy waste, making it a greener alternative to conventional modes of transportation. The HTS system promises quieter and cleaner transit, aligning with global efforts to combat climate change and reduce carbon emissions. As the world watches China's advancements in high-speed rail, the implications for urban development are also significant. Ultra-fast rail systems can redefine economic landscapes, allowing cities to be connected in ways that prioritize efficiency and accessibility over traditional car commutes or airport proximity. This could lead to the creation of regional megahubs, bolstering tourism and decentralizing densely populated areas. In contrast, the United States appears to lag in its infrastructure ambitions. While California's high-speed rail project has faced numerous delays and budget overruns, discussions about high-speed rail in other states remain largely theoretical. The contrast between China's rapid advancements and America's stagnation raises questions about the political will and vision required to pursue such transformative projects. In conclusion, China's maglev train achievement at 620 miles per hour is not just a technological triumph, it is a significant leap forward in the realm of transportation. This milestone has the potential to redefine travel dynamics both domestically and globally, signaling a future where high-speed rail could become the norm. As China continues to push the boundaries of innovation and infrastructure development, it challenges other nations, particularly the US, to reconsider their approaches to transportation. The race for high-speed transit is not merely about speed but about asserting leadership in a rapidly evolving global landscape. China's Maglev train reaching a speed of 620 miles per hour presents several counterintuitive insights that challenge common perceptions about transportation technology, national capabilities, and global competition. 1. Train versus air travel. The notion that trains traditionally slower than planes can now exceed the speed of commercial aircraft is counterintuitive. Most people associate air travel with speed, yet this development highlights the potential for rail technology to redefine travel dynamics. The fact that the Maglev can complete the Beijing to Shanghai route in just 2.5 hours compared to the 5.5 hours on current high-speed rails raises questions about the future viability of short-haul flights. 2. Technological leadership. While the U.S. has long been considered a leader in various technological fields, China's rapid advancements in Maglev technology showcase a shift in that narrative. The idea that a developing country can outpace a historically advanced nation in such a critical infrastructure area is surprising. It suggests a potential realignment in technological supremacy, indicating that innovation can thrive outside traditional powerhouses. 3. Environmental considerations. The increase in speed does not come with a proportional increase in energy consumption or noise. The Maglev train's use of high-temperature superconducting technology leads to less energy waste and quieter operation, which contradicts the common assumption that higher speeds correlate with greater environmental impact. This efficiency challenges the stereotype that sustainable transport solutions must inherently sacrifice speed. For geopolitical implications, the advancements in China's rail technology are not just about transportation, they are a strategic maneuver in global politics. The idea that transportation infrastructure can serve as a geopolitical tool is often overlooked. China's rapid progress signals a shift in global transportation paradigms, placing pressure on other nations to innovate or risk falling behind. 5. Intellectual property concerns. The origins of Maglev technology, initially developed by Siemens, bring to light the complexities of global innovation. The narrative that China stole or appropriated this technology during its development phase raises intriguing questions about intellectual property and the nature of technological advancement. It suggests that the line between innovation and appropriation is often blurred, challenging the conventional wisdom that technological progress is linear and wholly owned by one nation. 6. Urban development. The implications of high-speed rail extend beyond mere transportation. They can reshape urban development and economic structures. The idea that cities could evolve into megahubs due to high-speed connectivity challenges traditional urban planning paradigms, which often prioritize car-centric designs. This shift prompts a re-evaluation of how we envision future cities, revealing that speed and connectivity could redefine urban landscapes more significantly than previously thought. 7. U.S. infrastructure stagnation. The stark contrast between China's rapid advancements and the U.S.'s struggles with high-speed rail projects reflects a larger societal issue regarding ambition and execution. The notion that a developed nation like the U.S. can lag in such an essential area of infrastructure challenges the perception of American efficiency and innovation. It suggests that systemic issues, including bureaucratic inertia and a lack of political will, can stifle progress and lead to a significant disadvantage on the global stage. 8. Public perception of innovation. The idea that Maglev technology, once seen as a futuristic dream, is now a reality challenges public perceptions of what is possible in transportation. This shift highlights the role of public imagination and media in shaping perceptions of technological feasibility, suggesting that societal acceptance can influence the pace of innovation. 9. Investment priorities. The discussion around U.S. investment priorities, where funds for infrastructure seem to compete with defense and other sectors, highlights counterintuitive dynamics in national budget allocations. It challenges the idea that a nation's capabilities are solely determined by its wealth. Rather, it raises the question of whether political priorities can stymie potential advancements in critical infrastructure. 10. Cultural perceptions of speed. the fascination with speed in transportation often overlooks the cultural contexts within which these technologies develop. The rapid acceptance and implementation of maglev technology in China compared to the cautious and often contentious discussions in the US reveal deeper cultural attitudes toward progress, risk, and the future. This disparity suggests that cultural factors significantly influence technological adoption and innovation trajectories. In summary, the achievement of China's maglev train reaching 620 miles per hour reveals a multitude of counterintuitive insights that challenge established norms and beliefs regarding transportation technology and geopolitical dynamics. It underscores the need to reassess our understanding of innovation efficiency and the future of global connectivity. China's maglev train reaching a speed of 620 miles per hour is not just a remarkable engineering feat. It signifies a larger narrative of technological advancement, geopolitical positioning, and the future of transportation. Here are some critical aspects of this development that are often overlooked but hold significant implications. 1. Technological superiority and innovation. Many reports focus on the record speed itself, 620 miles per hour, but the underlying technology is equally important. The high-temperature superconducting HTS technology used in this maglev train represents a substantial leap in efficiency and performance. What often goes unnoticed is the energy implications of this technology. With minimal energy loss and noise, HTS maglev systems could redefine how we conceive energy use in transportation. This technology not only promises speed but also a more sustainable mode of transport, potentially paving the way for greener alternatives in a world increasingly focused on reducing carbon footprints. 2. Geopolitical implications. China's technological achievements in high-speed rail are often framed within the context of its competition with the United States. While many people are aware of the challenges the U.S. faces in developing its high-speed rail systems, few grasp the broader implications of China's success. The advancements in maglev technology place China in a favorable position on the global stage, allowing it to export both technology and expertise to other nations. This not only enhances China's economic clout but also establishes it as a leader in the transportation sector, influencing global standards and practices. 3. Historical context of technology transfer. The origins of maglev technology, initially developed by Siemens in Germany, highlight issues of intellectual property and technology transfer. This historical context is often glossed over in discussions of China's achievements. The narrative that China stole technology during a testing phase is a significant part of the conversation about global competitiveness and innovation. Understanding this context helps to frame current tensions regarding technology transfer and intellectual property rights in the global marketplace. 4. Impact on urban development and economy. The transition to ultra-high-speed rail systems like the maglev train is expected to reshape urban landscapes and economies. While the speed of the trains is a major talking point, the potential transformation of cities is often overlooked. As travel times between major urban centers decrease dramatically, we may see a decentralization of populations as people can live further from their workplaces without sacrificing time. This shift could reduce congestion in major cities and foster the development of new urban hubs, altering the economic dynamics of regions. 5. Comparison with U.S. infrastructure challenges. While many reports mention the slow progress of U.S. high-speed rail initiatives, they often fail to delve into the systemic issues that hinder infrastructure development in the U.S. The complexity of federal regulations, budgetary constraints, and political disagreements create a landscape where innovation is stifled. This is significant because it raises questions about the future of American competitiveness and infrastructure resilience. The stark contrast between China's rapid advancements and the U.S.'s struggles serves as a wake-up call regarding the need for comprehensive reform in American infrastructure planning and investment. 6. Environmental considerations. Beyond speed and efficiency, the environmental implications of maglev technology are profound. The reduced friction and energy consumption make maglev systems a cleaner alternative to traditional transportation methods. In discussions about climate change and sustainable development, the advantages of maglev technology often receive insufficient emphasis. Understanding the potential for maglev trains to contribute to a more sustainable future is crucial as nations grapple with reducing their carbon emissions. 7. Public perception and acceptance. Lastly, the public's perception of high-speed rail, particularly in the US, is a critical aspect that often goes unexamined. While the appeal of high-speed train systems is evident, the acceptance of such projects can be hindered by public skepticism, often stemming from previous failures or perceived costs. The successful implementation of China's maglev train could serve as a case study that may influence public opinion and policy decisions in other countries, including the US. Understanding the social dynamics surrounding public transportation initiatives is critical for future developments. Conclusion: China's maglev train achieving 620 miles per hour is a watershed moment that extends beyond mere speed records. It encapsulates a narrative of technological innovation, geopolitical positioning, environmental sustainability, and urban transformation. Recognizing the overlooked aspects of this achievement is essential for understanding its broader implications and for framing future discussions about transportation technology and infrastructure development globally. The advancements in maglev technology signal a shift in how we view travel sustainability and the potential for nations to lead in technological innovation. As China continues to push the boundaries of what's possible in transportation, it raises important questions about the future of global competitiveness and sustainability in the face of rapid technological change. 1. Technological advancements in maglev transportation. China's maglev train reaching a speed of 620 miles per hour exemplifies a significant leap in transportation technology through the use of high-temperature superconducting HTS technology. This advancement allows the train to operate with minimal energy loss and noise, elevating the travel experience to unprecedented levels. The absence of physical contact between the train and the tracks eliminates friction, resulting in smoother and faster travel. This achievement not only surpasses conventional rail speeds but also outpaces most commercial airplanes, thereby redefining the dynamics of domestic travel. The implications extend beyond mere speed. They encompass energy efficiency and sustainability in modern transit systems. 2. Impact on domestic and global travel dynamics. The potential shift in travel times due to the maglev train technology is transformative. For instance, the current 5.5-hour journey from Beijing to Shanghai can be reduced to just 2.5 hours. This presents a compelling alternative to air travel, which is often plagued by delays and congestion. The efficiency of maglev trains could reshape the entire travel landscape, promoting regional connectivity and making high-speed rail a viable option for a broader audience. Moreover, this innovation may catalyze a shift in urban planning and economic development as cities could become interconnected through high-speed rail networks, facilitating greater mobility and economic activity. 3. Geopolitical implications and global competition. China's rapid technological advancements in high-speed rail stand in stark contrast to the struggles faced by the United States in developing its own high-speed rail systems. While the U.S. grapples with bureaucratic challenges and budgetary constraints, China is making significant strides in transportation infrastructure, positioning itself as a leader in this field. The geopolitical implications are profound, as China's success in high-speed rail technology not only enhances its domestic capabilities but also strengthens its position on the global stage. This could lead to shifts in international transportation standards and norms, as other countries may look to China as a model for high-speed rail development. For historical context and intellectual property concerns, the origins of maglev technology, initially developed by Siemens in Germany, raise important questions about intellectual property and technological transfer. China's adoption and enhancement of this technology highlight the complexities of global competition in transportation innovation. The historical context provides insight into how nations navigate technological advancements and the potential tensions that arise from technological appropriation. Understanding the evolution of maglev technology is crucial in analyzing the broader narrative of technological development and competition among nations, as well as the ethical considerations surrounding innovation and intellectual property rights. 1. The development of the Concorde. The Concorde was a turbojet-powered supersonic passenger airliner that operated from 1976 until 2003. Designed and built by a British-French consortium, it was capable of cruising at speeds over twice the speed of sound, about 1,354 miles per hour, allowing it to fly from New York to London in approximately 3.5 hours. The technological advancements in aerodynamics, materials and engine design that made the Concorde possible were revolutionary at the time, much like China's recent strides in maglev technology. However, the Concorde faced challenges such as high operating costs, environmental concerns, and restrictions on supersonic flight over land. 2. The Shinkansen bullet train in Japan. Launched in 1964, Japan's Shinkansen was the world's first high-speed rail system, originally designed to connect Tokyo and Osaka. It has evolved over the decades to become a symbol of technological advancement and effective public transport. The Shinkansen trains can reach speeds of up to 200 miles per hour on certain lines. The success of the Shinkansen set a precedent for high-speed rail systems globally, influencing countries like China to invest in and develop their own high-speed rail networks. Japan's commitment to speed, safety and efficiency continues to resonate in the context of China's recent maglev achievements. 3. The Eurostar and Channel Tunnel. The Eurostar is a high-speed train service connecting London with Paris and Brussels through the Channel Tunnel, also known as the Channel, which opened in 1994. This project represented a massive engineering feat and a significant advancement in international rail travel. The Eurostar trains operate at speeds of up to 186 miles per hour and have provided a seamless travel experience between major European cities. The establishment of the Eurostar demonstrated the potential of high-speed rail to enhance connectivity and economic ties across borders, similar to how China's maglev advancements aim to revolutionize domestic travel and position the country as a leader in transportation technology. Future outlook: the impact of China's maglev train achievement. China's recent milestone in high-speed rail technology, with its maglev train reaching a speed of 620 miles per hour, signals a transformative shift in transportation not only within the country but also on a global scale. This achievement, which outpaces most commercial aircraft, has several implications for the future of travel infrastructure and geopolitics. 1. Transforming domestic travel. The immediate impact of the maglev train's speed will be on domestic travel within China. The reduction in travel time, transforming a 5.5-hour journey from Beijing to Shanghai into just 2.5 hours, will likely encourage more frequent travel between major cities. This could lead to increased economic activity. Shorter travel times can facilitate business interactions and boost tourism, with cities becoming more interconnected. Regions that were previously considered remote may experience economic revitalization as they become more accessible. Urbanization and regional growth. The emergence of high-speed rail hubs may lead to the development of new urban centers. Cities could expand as people are drawn to the convenience of rapid transit, potentially alleviating congestion in major metropolitan areas. 2. Environmental considerations. Maglev technology presents significant environmental benefits by offering a greener alternative to traditional modes of transport. Reduced emissions, with less friction and noise. Maglev trains consume less energy and produce fewer emissions compared to cars and planes. This aligns with global sustainability goals and presents a model for eco-friendly transportation. Shift in transportation preferences. As more people opt for high-speed rail over air travel, there may be a gradual decrease in aviation-related carbon footprints. This could shift public and governmental focus toward enhancing rail infrastructure as part of climate strategies. 3. Global geopolitical dynamics. China's advancements in transportation technology underscore a broader geopolitical narrative. Technological leadership. By achieving such high speeds in rail transport, China positions itself as a leader in transportation innovation, potentially influencing global standards and practices in rail technology. This could lead to increased investments in Chinese rail technology abroad, furthering its soft power. Competition with the West, as the U.S. struggles to develop its own high-speed rail systems. The contrast between Chinese and American infrastructure development may deepen. This may provoke discussions about national priorities and the importance of investing in modern infrastructure. 4. Rethinking infrastructure investment. The success of China's Maglev train may inspire other nations to reassess their transportation strategies. Investment in high-speed rail. Countries that currently lag in high-speed rail may feel pressured to accelerate their own projects to remain competitive. This could lead to a global renaissance in rail transport with increased funding and innovation. Public-private partnerships. The model of collaboration between government and private sectors in China's rail development could serve as a blueprint for other nations, emphasizing the need for swift execution and innovation in infrastructure projects. 5. Future of urban mobility. The introduction of ultra-high-speed rail could redefine urban mobility and infrastructure planning. Integration with other transport modes. High-speed rail systems may encourage the development of complementary transport options such as electric buses, bike sharing, and pedestrian-friendly urban layouts, creating seamless travel experiences. Smart city initiatives. Cities may leverage high-speed rail as part of broader smart city initiatives, integrating technology to improve transport logistics, reduce congestion, and enhance the overall quality of urban life. Conclusion. China's Maglev train achievement at 620 miles per hour is not just a technological marvel, it represents a paradigm shift in transportation, environmental sustainability, and global geopolitics. The implications for domestic travel infrastructure investment and urban planning are profound. As other nations observe China's advancements, there may be a newfound urgency to innovate and invest in high-speed rail systems. In the coming years, the landscape of transportation could be dramatically altered, redefining how people move, how economies function, and how nations compete on the world stage. The future of land travel is poised to be not just faster but also more sustainable and interconnected, with China leading the charge.